This is the Survival tab. It's used for plotting from a survival model, specifically the Cox proportional hazard model and a mixed effects Cox proportional hazard. This will allow you to produce a survival plot to test Schoenfeld residuals and to do mixed effects Cox proportional hazard modeling. Let me first go back to the Model Builder tab. We're going to use the prostate data from Chapter 21 of Regression Modeling Strategies. Time to event is our outcome. We'll use the following predictors. And our censoring variable is not alive. We will use a Cox proportional hazard with censoring. Let me type in not alive. And now we will begin to model, but before we do that, let's add in our splines, and we'll use those for the following variables: age, weight, blood pressure, HGSG, SZ, and the log of AP. We'll add the splines, and now we're ready to begin modeling. Our model ran. We now return to the Survival tab. RX, I believe it's for estrogen dose, is the variable that we have in our plot. We can produce other survival plots for our various predictors, but let's use RX. We'll go with the defaults for now. Go to number 4 and we'll create the survival plot. And we have it here, although we may want to change the dimensions of the plotting space. So let's increase the lower y-axis limit. We'll change that to 0.45. And let's also change the x-axis a little bit. We'll try to squeeze in the labeling for our different curves. Let's go up to 77. And let's go with confidence bars instead of bands. Might be a little easier to see the confidence intervals. And let's scroll down to our residuals. We have natural splines, and we see the terms there. But let's look at the Schoenfeld residual for RX, which we see doesn't have a significant Schoenfeld residual there, but we can see, we can also see that by seeing the wobble around 0 in our Schoenfeld residual. So let's now go back to the model builder. We're going to use the EORTC data set from the Cox ME package by Terry Thurnau. Let's turn this to no for the moment. Our outcome is the variable y. Our predictor is the treatment variable, TRT. We are using censoring, and our censoring variable is unsense. And now we will run the model. We return back to the survival tab. And we actually have different settings, but let me Actually, we have splines, and that's causing an issue with the display, so I turned that off. I'll go back to the survival display. We get our survival plot. Let's return the lower y-axis limit value to 0. And let's go with confidence bands. We have a binary intervention variable. And we also see our previous plots. So let's go to the mixed effects model. We just need to select a clustering level variable. And for this data set, that's the center. We will run the mixed effects Cox proportional hazard model. We get our regression results here. We have our fixed effects, and then we have our random effects, and our between group random effect is the standard deviation is 0.329, the variance is 0.108. We get various statistics to assess our model. We have the likelihood ratio test for adding a random effect into the model, and that's our center variable. We have the Cox-Snell pseudo R-square value, and we have the intraclass correlation, and we have the median hazard ratio, as well as a reduction in between group variance. In this case, we didn't really reduce it, so that's why we see a negative value. But we can see the frailties in this plot. This shows the positive and negative frailties, and those values are sorted accordingly. And we can see which centers would give you a greater chance of the outcome Y versus those who would have a lower chance. The dashed lines represent one standard deviation for our random effects, which is the value of 0.329. Below that, we have the random effects sorted, the frailties sorted alphabetically by the response value of the different centers, as well as numerically, which is identical to what we have in the graph. And if we want to save the model fit, we just click yes, name our model fit, and we download it to our directory.